Well, hey there, freaks. It's your boy Marty here to introduce this week's episode with Elichai Turkel, who participated in the Chaincode Labs summer residency this summer. Elichai's incredibly intelligent and talented young mind in Bitcoin. We talk a lot about Schnorr signatures, like pay to contract and what you can do with sidechains, the multi-sig functionalities that will be enabled, protecting hardware wallets, and a bunch of other stuff. Including cryptography papers and how they're poorly written, or not poorly written, just too heady for some people attempting to understand a subject. This episode of Tales from the Crypt is brought to you by the Cash App. You freaks already know all about them, and if you don't, let me tell you a little bit about them. The Cash App is an incredible app. It's the number one finance app in the App Store for the last 2 years, probably more at this point. And Cash App allows you to do a bunch of things, including buy and sell Bitcoin. So you can buy Bitcoin right from the Cash App, start stacking sats today. You can also send your Bitcoin off in exchange to a private wallet, straight to Wasabi if you'd like. And you can also send Bitcoin to the Cash App now. And on top of that, they have an incredible boost program where you get a personalized debit card, put your signature on it, a little Bitcoin sign, lightning thing, whatever you so feel. And you go to partnering merchants that are in the boost program. You turn on the boost. For example, I went to Whole Foods, bought a few steaks over the weekend, turned on my Whole Foods boost, saved 5% while shopping at Whole Foods. So go check out the Cash App today. And when you download it, if you haven't done so already, make sure you use the promo code STACKINGSATS. That's one word, Stacking Sats, STACKINGSATS. You're going to get $5, and $5 is going to go to Owls Across, a charity very near and dear to our hearts here at TFTC. I hope you enjoyed this episode with Elichai. I know I had an incredible time sitting down and talking about all Bitcoin stuff with him. So enjoy.
Tales from the Crypt.
What is up, freaks? Welcome back to Tales from the Crypt. It's your boy Marty Bent here on a Friday morning, sitting down with a guest who I feel terrible. The roundabout way he had to get here this morning, mixing up the address and went to a different part of Brooklyn, but is now here. Luckily, we called him an Uber. He's here now. We're going to learn a lot about Schnorr, what he's been working on this summer at the Chaincode residency, and how I got into Bitcoin. I'd like to introduce you freaks to Elichai Turkel. Elichai, welcome to the podcast.
Thank you. Honored to be here, Marty.
I'm pumped to have you here. It was we met. I believe it was the first day of the residency this summer when you guys all went to BitDevs, and then we went to the bar after.
Yeah, I think it was definitely the first week, but maybe the second or third day.
Yeah.
But yeah, it was a good bit dev.
Yeah, you were an inspired person when we met that night. Very, very enthused about Taproot and Schnorr, and a bunch of other things. But before we dive into what you've been working on this summer, we've been rapping here for like the last 15, 20 minutes. You have a very interesting story. You're the youngest member of the residency this summer. So let's talk about how you got into. You're very cryptography focused, correct?
Yeah. Yes, I love the cryptography side of Bitcoin.
Yeah, so let's talk about how you got into cryptography and then found your way to Bitcoin as well.
Well, I started learning programming at 9th grade, and then like I learned about this cryptography thing that you could encrypt something that not even you can decrypt it, but only the recipient, which is awesome. And like signing without the ability to fake signatures, and like I fell in love with the cryptography. And then I learned about a coin called Bitcoin, which utilizes this cryptography to create like a whole world of how market can work and how coins work. Like that was crazy for me, and since then I don't think I never left Bitcoin.
And so we were talking about this before we hit record too. You sort of align with Bitcoin's political nature and the fact that it's a freedom-enabling tool, censorship resistant and peer-to-peer distributed. Why do you like these attributes of Bitcoin in particular?
Yeah, I personally believe that the economy is too complicated to try to manipulate and control, and the only way to get like close to optimized economy is by having a free market, and no one is trying to manipulate or to force incentives or anything. Just let it be, and either it works the best or we'll see.
Yeah, and no, yeah, and like if not only a free market, but like a free market for money, where people can coalesce on a hard money that is borderless, and you're able to trade, create a metric system for value is what we've been trying to get across here on this podcast.
Yeah. So Bitcoin takes, I think, the idea of free market a step forward. Like usual free markets only talk about products, but Bitcoin says let's take even the coin to a free market. Like there shouldn't be a controlling entity that creates coins and manipulate them and does like manual inflation because some guy decided we need more inflation or less inflation. Bitcoin says like we should have a strict rules that no one can really manipulate in a non-negligible way, and everything should be free market other than that.
Yeah, so you became enamored with Bitcoin pretty quickly once you found out there was cryptography related to it. And like, so what happened after you discovered it and sort of became enamored with it? How did you start working in or around Bitcoin? Were you just in the background lurking, building stuff, or were you just like an enthusiast for a certain amount of time?
Yeah, so I was in high school. So most of the things I was like, I didn't really even have a computer. I had a shitty old laptop that couldn't run almost anything. So we didn't have any GUI. It was like Arch with nothing other than a terminal. So I compiled the Bitcoin core node and ran it, and I tried mining, but it was too late really for mining on laptops. And then for a while I got really into double spending. How does like unconfirmed double spending, how does the standardized rules work, and how could you use them and use miners rules to manipulate transactions and create double spends. And like I did a lot of work like around and like some tools here and there, but the residency gave me the opportunity to really dive into the core code.
So what was your so obviously you've been at the Chaincode residency all summer. What was your experience applying and then getting in? Like what did you send with your application, if you're willing to disclose?
Yeah, so actually I also applied last year.
Mm-hmm.
But last year they didn't have like a formal application. You just had to send an email, and I literally just sent Chaincode an email saying I want to be at the residency, and that's it. So they obviously ignored that email. But this year they had like a formal application, and I actually like we sent I think the CV and some explanation of why I'm enthusiast. And one thing I want to thank Carl Dunn, which I knew working on Rust Bitcoin, and he's in Chaincode, and he helped me like to make sure that people actually look at the application because there was hundreds of applications.
Yeah, shout out to Carl, incredible person working on Bitcoin Core. Everybody looking to geeks. You want to make Bitcoin bootstrappable, and what's the slogan he likes to throw out there?
I don't remember the exact slogan,
either.
but Geeks is very awesome, and I think it's important work for Bitcoin.
Yeah. And so, yeah, so you alluded to it there. You are drawn to the Rust Bitcoin implementation?
Yes. One thing that I really think could be useful is that Rust is basically a language that is supposed to be very similar to C and performance-wise to C, but without like the dangers of undefined behavior and memory allocations, which I think is like it can take a lot of the security aspects of Bitcoin a step forward. But it's still a young language, so we shouldn't run to changing stuff. But I think Andrew Polstra and Carl and Matt Corallo are doing great work and related to starting to build some stuff in Rust for Bitcoin, which I think hopefully in the future is going to be exciting.
Yeah, so what is it particularly about Rust that makes that is attracting the talent of developers? Is it just easier to work with or more compact?
Yeah, I think it's mostly because it's a very ergonomic language, but it doesn't have a garbage collector. So you don't have the overhead of something trying to manage the memory for you. So it's an ergonomic language that doesn't have the dangerouses of C with the dangling pointers and free after free and all of those stuff. But it also doesn't have a garbage collector. It just gives you a very strict rules of what they call lifetimes. So like how long should memory live, and it's all verified at compile time. So there is nothing when the program, like for example in Java, when the program runs, there is some sort of like an engine called the garbage collector, which checks if you stopped using something and then it removes it from memory. Okay, on the other hand, in C, you need to manually allocate and deallocate by yourself. Rust says something else. They say, let's have compile time rules of how long will every object live, and that's it. There's nothing to deallocate memory for you, and you don't need to deallocate yourself as long as you're using the rules correctly, and they can be all verified on compile time. So there is no dangerous stuff that could happen on runtime.
Interesting. So you're setting parameters through which each function can run over a certain period of time?
Right. So like, for example, if you allocate, let's say, a vector of transactions inside a function, the second the function exits, this is automatically deallocated. You don't need to worry about it.
Interesting. Yeah, so it seems more efficient, if anything.
Yeah. So in theory, and people actually did prove it, that even though Rust should be a bit less performant than C, because of that, because you don't need to manually do stuff, and it might even be more performant in some use cases, and people actually showed it.
Interesting.
Yeah.
Yeah, it's fascinating. I've talked to a lot of Matt and Carl in particular, and Andrew, who are Rust developers, and Rust is something that's fairly new to me as a concept in the last couple of years. It's crazy how many different languages there are, and how as an engineer you'd have to sort of understand each of them and the semantics within each of them, and then adapt while you're coding. It's just something my little brain cannot handle, I don't think.
Yeah, engineers really love their programming languages.
Right?
Yeah.
You get you want to talk about toxicity. I mean, there's some toxicity against the programming language communities, you know.
Yeah, like if people are talking about toxicity in Bitcoin, like they should see the broader community, how people can shame each other on using C# or Java or Rust or Haskell or whatever.
No, it is. It's a fact. Like, as somebody who's been an outside observer, and I got into Bitcoin via economics and finance, and so that was my focus of study until my early to mid 20s, and then have sort of tried to learn more about the engineering and understanding how apps and programs and software works, and it's been fascinating to learn that there's a strong history, a lot of personality, and a lot of intricacies and nuances that one has to understand, like when using an app and looking at a phone and stuff like that, and different types of technology that it's magic to most people.
Yeah, it's pretty amazing the amount of like layers we have into everything that we use day to day, and even engineers, and like we don't really know most of the, like we go on a train, and even as an engineer you don't really know how many layers are in to just making the train works, and how many people are involved in that.
Yeah, and how interconnected and sort of dependent each system is on the other. Like we're finding out in the last couple of weeks, we were talking about it earlier, the Erebus attacks, which can target or ISPs can pull off because of their access to data and the power that they wield. But that's something, in my mind at least, that has not been paid attention to. Like P2P network attacks in Bitcoin in particular has gotten not as much attention as say 51% attacks and stuff like that.
Yeah, we a lot of time tend to forget that all of the new and cool stuff we have today, like Facebook and Instagram, in the end, they all rely on this very old technology. Like, old doesn't mean bad, but very like primitive routing and all of that. Like, all of this can be attacked and is being attacked all the time. And like it's good to remember that there's all these layers, and it's not magic in the end. No, sadly.
It's very much not magic, but it does sometimes surprise me and sometimes scares me to think of the percentage of the world that doesn't understand sort of like the layering of the technology stack that makes our world possible today. Yeah. Like what happens if all the engineers just leave and go to Mars?
Yeah, there's a joke among engineers about the COBOL languages. That's like an old language for mainframes.
Yeah, for banking system.
Yeah,
America.
exactly.
Yeah.
So that no one is knows this language today, and like there's be one day that there's only gonna be one engineer that knows COBOL, but all the banks are still gonna be built using that, and he'll be like the only guy on earth that knows what the heck is going on.
It's a joke, but it's true. Like,
Yeah.
do you know anybody learning COBOL?
Personally, no.
It's this is why we Bitcoin freaks, creating an alternative system to this banking system built on COBOL and easy money printing.
Yeah, and I think it's also connecting back to geeks. Like, why do we want to be able to control all of the stack as much as we can? And I think hopefully in the future there is also a project called RISC-V, which we could use, which is open source hardware. Like, geeks get us to the end of open source software that it's all bootstrappable. I think hopefully in the future even the hardware could be bootstrappable.
What was that? Serve 5? What'd you call
RISC-V.
RISC-V.
Yeah.
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 It's similar to Purism. They're trying to.
Yeah, but Purism is until like an end. Like in the end, Purism still uses, as far as I know, x86 Intel CPUs. RISC-V is creating a new instruction set with 100% open source hardware, and it's pretty promising.
How do you think we transition the world to these types of systems? Do you think people will want them? Because they're harder to use now, right?
Yeah, so currently they're pretty hard to use and expensive, but hopefully in the future, like, it's gonna be a slow transition. But even now, people are talking about moving servers to use ARM, which is the same processor we have on our phones. Which also, by the way, the processor on our phone and on the PC is totally different. Like, that's ARM, that's x86. And yeah, having a new instruction set is hard, but hopefully that could control because it's open source and bootstrappable.
Yeah, and no, it's the fact that it's open source and bootstrappable is, I think, something that we humans are just coming to grips with, right? Because the open source nature and the bootstrappable nature of these systems creates these feedback loops where if you're contributing, like you're contributing to Bitcoin Core, and you add value to the system and you have skin in the game in the system, you add value to yourself at the end of the day. So incentives are aligned in these open source communities if they're doing it correctly.
Yeah, and it gives us like more understanding of all of the stack. Like, we don't know if our incentives and, for example, Intel's incentives are aligned because they're doing the CPUs in the end. But the second it's all open source and we can control everything end to end, the incentives are exactly more aligned and more like open.
And so was cryptography your first, the first place where you dipped your toe in the open source community?
Yeah, I think Bitcoin was Bitcoin and other cryptographic tools were the first things I've saw on GitHub and used. Actually, even at the start, I used SVN, which is like what was before Git. And I think with Bitcoin, I learned about Git and GitHub and started using it.
So, again, you're the youngest resident at the residency this summer. Have you ever had like a job at like a traditional software company?
Yeah, so I worked for the past year and a half in a company called Enigma, which they're actually in the Ethereum ecosystem. Yeah.
I'm kidding.
And before that, I consulted to a company for a while, which called GAP 600 they're doing insurance against Bitcoin double spends. But that wasn't like a traditional job. It was part-time consulting. I had one traditional job, which was at Enigma for a year and a half.
And was that like a product manager, CTO, stand-up meetings every week type of job, or were you able to work on like open source stuff?
Yeah, they're also open source.
Yeah.
Like, it's more like it was less like working at Microsoft and more like working on a very, very small startup.
Yeah. No, that's what I'm trying to get at here. Like, are you like
Yeah.
you're this young, like at Chaincode residency right now, and can you find yourself falling into like a not even a waterfall style like development team, but even an agile team with a very clear target where Bitcoin is not as clear. I mean, it's clear the end goal is clear, but how to get there is not as clear. And sort of just working on this open source technology, is it better than working for like a company where you're being directed to what to work on?
So, as we've said, I've never worked in an enterprise, so it's hard for me to say. But yeah, I personally really love the idea of open source and the way that even if you work at a company which does open source, you're more you have more freedom than usual enterprise, because in the end it's all on GitHub and everyone can see and comment. So it gives you more freedom. Not unlike enterprise, when like if the CTO or the team leader decides something, you don't have a lot to say in the matter. I hope to still be in open source for the rest of my life because I love the ideology of it. I think code should be free and open. And I think it's proved itself over the years, especially when it comes to security and cryptography. Closed source have been broken again and again. Also open source, but less severely. A good example would be there's been a research paper last year, I think, on the cryptography on hard drives, SSDs. And they found a couple of very major companies like Crucer and other ones and even Samsung, that the encryption on the SSD was not really. Some of them weren't even encrypted at all. They just used the password as authentication and that's it. And they were encrypting with a default.
That's pretty bad.
Yeah, it is. And no one knew about it because it's all closed source. And the research paper found it by reverse engineering the SSDs, which I think this would have been prevented in open source in it, and it probably wouldn't touch the margin of Samsung, because they shouldn't care about the code that runs on their SSD. They're producing SSDs.
Yeah. They should want them to be secure so they have a better product to push.
Yeah. And if there were open source, we probably would have found it long ago.
Well, that's the interesting thing about the particular time that we find ourselves living in right now, because like cryptography, military grade encryption, and open source as an ethos for building software and things online is so new. Like the internet is so new still, like, and we as a species are still adapting to this thing that is barged into our lives. And we were talking earlier, I was like, holy crap, it's crazy to see how young you are and how much you're contributing at this point. And you were like, you should see the kids younger than me, like, and what they're doing. And like so I think the speed at which people can catch up to like the learning curve because of the access to information and the proliferation of open source in particular is helping people like be able to leverage this stuff faster at a younger age.
Yeah, I think we live in a very amazing era, and I'm really excited to see how all of this is gonna turn up in 50, 60 years.
So how, like, what are these kids doing that are surprising you these days?
What was that? There was, that's not even new. I read yesterday about Erdos. He's a mathematician, and he's like, he proved that between every number and its square, there is at least one prime number. And he proved that at like 20, and that was a very open problem for a very long time. And it's like, there's always, no matter what do you do, there's always smarter people, and there's always like these crazy like people doing. And you can see, for example, Benedict, he's like so young, and he just published like for the past 2 years so many papers. Like it's pretty awesome.
So many papers on what?
He published a paper on VRF, and he did a lot of the bulletproofs. You probably heard about bulletproofs, which is a zero-knowledge proof that is very cheap to do range proofs with. And he, together with, I think, Andrew Polstra and Peter Willey, they published like the bulletproofs papers, and I'm not sure exactly how old is Benedict, but I think he's like 20, 21, maybe 22. But I don't count, like, I'm not sure exactly how old is he, but he's very young, and like Bulletproof is amazing. I think it's crazy to see like the age that goes lower and lower. That in the past, I think people were like, before you're 40, like no one cares about you.
Yeah.
And today you can see very young people doing amazing stuff.
I mean, Matt Corral is a great example. Somebody got into this stuff very young as well.
Exactly.
And started contributing early. And that, again, I feel like the open source gives a lot of young developers confidence too, because if they ever do build up the confidence to actually try to contribute and get feedback that happens to be good or bad, it's like, all right, I went through this once, and it just encourages participation, right?
Yeah, I really hope that we're right, and both open source and in general the scientific method gives us a way to be more objective about people's ages and reputation, and this gives a very good like opportunity for young people to succeed and do a lot of awesome stuff.
Yeah. So let's talk about the awesome stuff you've been working on this summer. What have you been? I mean, I've watched your presentation that you gave last week at BitDevs. I'm sorry I haven't been showing up to the meetings. I'm sorry. On Schnorr, explaining Schnorr and diving into a couple concepts that I want to talk about today. In particular, what you can do at multisig, and then pay to contract, and the things that you can do, like protect hardware wallets and interact with sidechains.
Yeah, so I think that Schnorr is pretty amazing, and it's time that we switch to this because ECDSA is not the best thing.
Yeah, so talking about the time to switch to it, let's talk about Schnorr's history and why Satoshi didn't pick it when he was originally writing the source code.
Yeah, so sadly, which this actually also connects to the ideology and open source that we've been talking about, Schnorr published his paper even before ECDSA was standardized, but he decided to patent it. I still personally don't understand how you can patent math, but that's the laws, and he patented it, and because of this, mostly because of this, ECDSA was very different than Schnorr, even though Schnorr is superior in any way known. And yeah, so because of that, there was the idea of Schnorr, but there was no standard on how to use Schnorr and in which way and what. So Satoshi probably just chose the common thing that everybody used, which was ECDSA, because that was a standard and it was in OpenSSL. And yeah, I think it's mostly because of the patent, which is pretty sad.
Yeah, especially when you consider the things that Schnorr enables that you described in your presentation, and now trying to figure out how to get it into Bitcoin is a headache we have to deal with now arguably because of the patent. Yeah,
so now that the patent has expired in 2008, I think, and now, thanks to Peter Wheely, Jonas Nick, Andrew, all of the great cryptographers at Blockstream, we have a very good standard that has been highly vetted on how to use Schnorr correctly and how to protect against other attacks that could be. And now that we have this standard, we can start integrating Schnorr into Bitcoin and get like the great stuff that I've talked about in the presentation and people have been talking about, like pay to contract and all of those.
Yeah, so let's talk about this great stuff. Like what excites you about Schnorr? So, and before we can get into what excites you, like how does it differ from ECDSA? I guess is a good place to start.
Yeah. So in ECDSA, there is I'll try to not talk about complicated math. Very simple. In ECDSA, you need to divide the signature by something. Okay? The problem in math in general, the second you have division, you can do linear stuff. Meaning, if I have something I have 5 and 8, I can easily add them up. But if I have 5 divided by 3 and 8 divided by 2, and these 3 and 2 are unknowns, it's very hard to add them up. Okay? So in Schnorr, there's no division, or what's called modular inversion, which is a fancy word for division. So because we don't have division, we can easily add things to the signature and remove things from the signatures and add 2 signatures up, which gives us a lot of very awesome stuff that we can't do at least not easy in ECDSA.
Yeah, and this particularly pertaining to multisig and enabling sort of off-chain functionalities, correct?
Yes, so in particular about multisig, there are ways to do multisig in ECDSA. The obvious one is what we're doing in Bitcoin currently, but that's you need to literally provide all of the public keys and all of the signatures and verify them like one by one. It's not really multisig. In papers that are proposing to do actual multisig in ECDSA are fairly complicated and involve some of them new assumptions. And with Schnorr, you can literally add up signatures and public keys. And using the MuSig, which was again published by Peter Wheely, Andrew, and all of their people, the MuSig gives you a way to do it more safely and like have a vetted, safe, proven protocol that is secure to just add public keys and signatures together and produce a multisig that looks exactly like pay-to-pub key.
Yeah, and this is a boon for privacy, efficiency, and again, more functionality out of the scripting, correct?
Yeah, so I think the second we use this linearity, as you said before, with off-chain stuff, we gain a lot, both in privacy and in cost efficiency, because, for example, in the multi-signature scheme, you don't need to provide all of the public keys and all of the signatures. So, A, you don't need to pay for them because you don't provide them. B, no one even knows there's been a multi-sig. It looks like pay to pub key and then it pays again and again. No one knows that there's been multiple parties. So, for example, it's very easy these days to see liquid payments, for example, because liquid uses a very big multi-signature. I don't remember exactly the numbers, but it's very big, and I don't think anyone else uses this big of a multi-signature. But with Schnorr and MuSig, they'll look exactly like my payments and yours. No one would be able to know that this is liquid or this is Coinbase, because they also, I assume, have some multi-sig.
Yeah, keep going.
Yeah, so like it gives us both privacy enhancements and cost efficiencies.
And what type of use cases do you see this enabling, or what use cases do you see this improving that are currently used, other than multisig?
Yeah, so now that the second we have Schnorr, we could do the stuff that we've talked about, like, for example, pay to contract. Pay to contract is a way to hide a script, a Bitcoin script, inside of the pub key that will only be exposed if it's used. So, for example, let's say Lightning. Okay, in Lightning, the usual transaction looks something like you pay to a 2 out of 2 multisig, and to spend this output, you either have a pre-image reveal or a time lock. Okay, all of this is visible, meaning you can see that the funding transaction is paying to a 2 out of 2, and you can see that the closing channel transaction has this complicated script. But if we use pay to contract, then first of all, with the MuSig, no pay to contract, just MuSig, in the funding transaction, you don't see anything. Okay, you just see pay to pub key. You don't know it's 2 out of 2 because of what we've said. But then, even in the closing transaction, if it's been cooperatively closed, then using pay to contract, we can hide that there's been a script. Okay, and it will look also like pay to pub key. But if it's been uncooperatively closed, meaning that they need to actually use the pre-image or the time lock, then they will need to reveal a script, but we can take it, but then you like expose the privacy, and then Taproot takes it a step forward. It says, okay, let's Merkleize, let's create a tree of different scripts, and then you just expose the correct path. Meaning that in the Lightning scenario, when you have both the time lock and the pre-image, you only expose one of them. So someone can see there's been a pre-image, but he cannot see there's been also a time lock. It's hidden. So this is also pretty much increases the amount of privacy.
Yeah, it seems like a no-brainer to get implemented, but that's the big question, and something I'd be interested to get your thoughts on is how do you get this, like, so Peter Will has proposed his Bip Taproot, which includes a few of these things, not all of them, correct? and it seems like, to me at least, that nobody wants to step forward and put together like a signaling path or something like that. And I think there's a lot of scars from the SegWit 2x battle and the from a couple of years ago that people are sort of like a little apprehensive to even put their neck out there to what's the word I'm looking for? Propose how we would soft fork this in.
Yeah, so I think a lot of people are still pretty scared because of the SegWit thing that we had. I really hope that all of the community will understand this is pretty much a no-brainer and it will be integrated without too much of a hassle, but still I think it's gonna require a discussion of how do we even signal? Do we want to use the same BIP9 as SegWit or maybe something else?
Yeah, so let's talk about the downfalls of BIP9. So BIP9 is the version BIP signaling for miners, correct? Where
Yes.
it's binary, they can signal whether or not they're ready. They can signal if they're ready or if they're not ready, and basically using that binary bit in BIP9. And we found during the SegWit wars that some mining pools were just playing with the market, and it didn't really turn out to be a great sentiment indicator, if you will.
Yeah, so I don't think anyone can really say what happened with SegWit because it was really weird. But yeah, we've seen that miners trying to influence the BIP9 deployments without some of them without having any valid like reasoning. Just I don't want to hypothesize why because I honestly don't know and I don't think anyone knows, maybe other than the miner themselves. But SegWit wasn't like a very good activation, and I think people are looking in other ways to activate Taproot without requiring the BIP9 deployment.
What would that entail, do you think?
That's a good question. I haven't looked too much into this, but one thing that can come to mind is, for example, the UASF, user activated soft fork. So, for example, users could add this to the code. Other thing could be maybe in theory signal through transactions. So the transactions are gonna signal instead of the miners. And then if most of the transactions are signaling this, then we activate.
So would you have to force transactions on people, like force people to transact, or
What do you mean?
like would the miners be using the transactions they aggregate to signal, or would individual users sending transactions signal while they make transactions?
Yeah, so in the idea I talked about, which I'm not even sure anyone is proposing or working on, is that, yeah, users will signal themselves in the transactions, but then you could argue again that miners can choose not to include these transactions in block and that way to influence again.
Well, and then like think about like the long-term hodlers who don't want to move their coins and don't want to transact. Like forcing an action on them could be weird as well, right?
Yeah, that's right. I hope there's good proposals on how to do this. I'm not sure there is a way to capture all of the Bitcoin users. Like hopefully we would want to know what the miners' opinions and what the hodlers' opinions and what the daily users and what the traders, because all of them are part of Bitcoin. I'm not sure there is a one way to catch them all. But honestly, like I don't think this requires too much. Like check log time, verify, got in without any discussion. Like I don't even think I knew about the exact dates of BIP9 for that. Like on SegWit I knew, and I knew everything about the UASF and all of that, but the check log time, verify, got in without too much.
When was that?
I think either right before SegWit or right after. I'm not really sure.
Okay.
But yeah, I hope Taproot and Schnorr would be something similar and will just get in without any community trying to prevent it and forking and all of that.
Yeah, just to steel man it. Like, what would an argument against it be? Like, I can't think of one.
One would be complexity, because the way Bitcoin works, we don't remove support for old stuff. We just add and add and add. And this incremental thing is adding complexity every time. Even when we simplify stuff, in actual code, it adds complexity because now we need to support the complex stuff in the past and the simple past stuff in the future instead of just the complex. That's in general a very big problem, I think, in consensus code. And there's been ideas of something called the big consensus cleanup and stuff like that. Like, let's simplify a lot of the code, hopefully without breaking consensus, but that's a problem with consensus.
Yeah, no, it's a very, very tricky problem we find ourselves in. So do you are you partial towards ossification as soon as possible, or are you as close to ossification as soon as possible? Because obviously it will never get to a point where you stop tweaking it completely.
I think we should start, like, most of the discussions around Taproot right now were being only in mailing list. What I want to do, and I like other people are doing as well, is trying to bring this discussion outside of the Bitcoin devs, and I think your podcast is helping with that. Like, that the community should actually talk about it, and then we can know that everything is fine and everyone, like, the second, if only developers talk about this, like, it's really hard to sense what's going on in the community.
Yeah. Now I'm going to try and talk about it as much as possible because I want this stuff. I mean, I think just from, and this is a huge topic on this podcast in particular, is privacy and transacting privately on the network, which is pretty hard right now. It's not impossible, and but it's pretty hard to transact privately. And I think Schnorr just would add to the incentives to transact privately with, I know you have to have a node online at all times, but things like P2EP and stuff like that. And the aggregating of signatures that is possible with Schnorr just helps for overall privacy. And that is, I think, if we are going to fight the state and that is an obstacle we have to overcome in the future, I think being able to hide from chain analysis companies is pretty essential.
Yeah, I think Taproot and Schnorr together are like a very big step towards a more private Bitcoin, especially private in the sense of chain analysis companies. Yeah, if we could hide most of the logic from the public, most of the logic in transactions, it will be really hard to differentiate between stuff. And this together with Wasabi wallet, for example, like, you could open and potentially even close channels while mixing in Wasabi.
Yeah, so that's another thing you were alluding to, of pay to contracts, with things you can do with, what is it, P2SB or PTSB?
PSBT?
PSBT, that's what it is. And hardware wallets. You were alluding to that in your talk last week as well.
Yeah, so PSBT is mostly a way to standardize how do we use transactions before we send them to the Bitcoin network, because in the past, most of the transactions were started and finished inside of Core, but today we have hardware wallets, we have mixers, we have a lot of this stuff, and we need to pass transactions that are either not signed or partially signed before we send them to the network. And we had no standard for this. PSBT is a way that we want to standardize this, and it's also called partially signed Bitcoin transactions. So that if you, for example, have a mixer and a hardware wallet and something else, like, you could have a multi-sig with 3 hardware wallets, 1 Ledger, 1 Trezor, and 1 another company, and you have the Wasabi wallet as a mixer, then you need to make sure that all of them can communicate together and it's fine, which currently I don't think that's the case. So PSBT says it's a way that if we standardize this and everyone is going to use the standard, then yeah, all of these wallets will be able to communicate. And no matter if the transactions contain a Taproot or contain a multi-sig or contain a Lightning funding channel or closing channel, PSBT should support this and be able to do all of that.
Yeah, it's fascinating seeing all these robust tools getting built on top of Bitcoin. Because you were talking about Musig earlier, we've been talking about Taproot, and now I always get it mixed up. PSBT, and then on top of that, things like Miniscript that came out earlier this week. It seems like a lot of people especially in the altcoin world, are focused on building more robust protocols that can do everything at the protocol level. But it seems like over time, especially this year, I feel like this year has been like a boon for tools being built on top of Bitcoin that just leverage the protocol's assurances and make it more robust.
Yeah, I personally really believe that the trustless and fully verified nodes is like the way to go. And that's not possible with a lot of those altcoins that try to do everything in the protocol. Like if you've ever tried to run an Ethereum node, I think we're close, if not even over the 1 terabyte blockchain, which is gonna feel like my laptop, and like it's not like it doesn't make sense to have a fully verified node, which I think is very important to the security of Bitcoin.
I do too, and it's funny seeing other projects not prioritize that, because in my opinion, it's like if you don't have that, it's not worth building these distributed systems, right? So have you watched Eric Wall try to download a full state change tracking Ethereum node from scratch over the last 12 days?
I didn't watch it, but I tried myself in the past, and it always failed at some point. I never got to have a full Ethereum node end-to-end working.
Even while you're working at Enigma, or?
Yeah, and before, like, I don't have anything against other technologies. I'm curious to see them and test them myself, and then if I don't agree with their security assumptions and the way they do, I wouldn't use them, but I still think it's interesting to test them. So I tried. Didn't work out well.
What kind of hardware were you using?
Just pretty good laptop. Like not some monster computer, but not something old, like a very good laptop. And it was like so much time, and I think it always failed, and I had to reindex, and I tried both in Geth and in parity, and it never really worked out. I don't think I've ever gotten to run a full Ethereum node.
Interesting. No, this is, so what would you consider to be like your must-haves for a cryptocurrency in terms of very small attack vectors? Like full nodes are obviously essential. I would agree with you, but like things like ISP distribution too, like we're finding out with the Erebus attack again. Like what are the areas? Here's a better way to phrase the question: what areas in Bitcoin are most vulnerable? Do you think we need to work on?
Okay, so if we're looking at Bitcoin, I think one of the biggest vulnerabilities are mining pools, which Matt Corallo is doing very great job with Better Hash to prevent that, because currently there's very little security in the pools, and you could steal hashing power and and like if you're an ISP, for example, in China, where most of the mining actually happens, you could steal a lot of the mining power and to manipulate Bitcoin, while the incentives of the Bitcoin doesn't protect us against that, because you don't have any skin in the game. You're literally stealing the mining power, which is, I think, a very big vulnerability.
Yeah, no, I would agree. So like things like Better Hash, which allow individual miners to construct their own block templates, would, even if the ISP did have control of that physically located mining pool, they would not be able to dictate the block template and which transactions are included in those blocks, correct?
Yes, Better Hash gives you the ability both for individual miners, as you said, to create their own templates, and I think some optional encryption and authentication, at least authentication, with the pool, that they know that what they got is actually from the pool and not from some man in the middle. And a lot of cool stuff that would hopefully make the mining pools more robust.
Yeah. And what would you consider like a acceptable number of full nodes running in the world? Like, do you think 10,000 is enough right now?
I don't think exact numbers are the way to measure it. I would hope that we have in the end between 5 to 10% of users running full nodes. I think more than that, like I'm talking about like a world where everyone uses Bitcoin. I don't think my grandmother should ever run a full node. I don't think it's reasonable. But I do think that 5 to 10% of the users should have full nodes.
Yeah. It's yeah, so do you see like a future in which there's like a Bitcoin expert in the family who runs the nodes, and you can connect through the family node if you must, but there will always be that family enthusiast who contributes to the consensus.
I actually never thought of that, but in theory, yes. Like today, I think every family have the one guy that actually knows how computers kind of work and helps everyone with their phone problems. So potentially he would have a full node and the family would connect to that. Yeah, that's interesting.
I can get down with that future.
Yeah, and I think that's even better than what I imagine. Like with that, you literally trust only your family relative which I think, like with most families at least, it's pretty good trust.
Yeah, it should be at least. I hope so. I hope you can trust your family out there.
I do. Yeah, I hope so.
No, but it's going to be fat, and that's the beauty of Bitcoin right now. Why I think it's so exciting to be a part of it, because we truly do not know how all of this is going to unravel, and the tendencies and the use cases that are going to be enabled, and how people are going to interact with it. But it is fun to wax poetic and think about a future where family members are running full nodes for other family members to connect to.
Yeah, and I think what's interesting is that not all of the community needs to agree on what the correct future, and we can see it, for example, in Electrum. Electrum is running their own different network protocol with different security assumptions for SPV or light wallets. And some people are fine with it, and we'll see in the future what's the best suitable for different kinds of people, and we cannot control the future. I think that's good.
Yeah. No, and it also, the fact that we don't know the future creates this opportunity to build a future that we see fit for ourselves. And again, Bitcoin's been this organic self-organizing system between developers, miners, holders, you name it. There's like people organically coming together around this protocol over the last decade. And that's the other thing. Like, so how long do you see Bitcoin persisting into the future? Do you see it as a system that's around for like millennia, a couple centuries, a couple decades? Like,
that's a hard question. I would say Bitcoin as we know it, I would give it a maximum of a few more decades, because like looking at the history of cryptography, for example, discrete logs are gonna break. Like I don't think any like cryptographic assumption was ever consisted more than a few hundred years. And quantum computers are doing some like interesting developments, not for any time soon, but maybe Bitcoin would be able to adapt with like evolution, and it's still gonna be Bitcoin even in 200 years. It's gonna be looking a bit different than today's, but it might still be Bitcoin. I don't know.
yeah, no, it's that's actually one of my favorite themes to follow on Bitcoin, is Bitcoin as a living organism, like Ralph Merkle talking about it replicating itself and stuff like that. And then people like Brandon Quittem who's written about Bitcoin as a slime mold, like a self-organizing system akin to slime mold fungi. And many others have written about Bitcoin as a living organism, and it does adapt, and it's because we're part of it, right? We're building it.
Yeah, I think it's part of the open source idea that there's not a single entity that controls the code, and it evolves over time, and even people that do criticize that in the end it's only a handful of people like approving merges into GitHub. Look today and 5 years ago, they were totally different people. Like that's the exciting thing about open source. Today there's only a handful of people, but 5 years from now it's totally different handful of people.
Yeah, it's like human bodies. Like our blood cells regenerate and die, and we don't have the same blood cells in our body that we did 10 years ago, but we're the same person, right?
Yeah, exactly. We don't need more and more blood cells. We just need them replaced.
Yeah, I'm getting heady here. We haven't even ripped out the herbal enhancements for this one. But no, I was stalking your Twitter account, and I saw that you were yelling at somebody for for excuse me, what's the word I'm looking for here? I'm losing my words today. Somebody for you yelled at somebody for recommending voting on blockchains. Why can't we vote on blockchains? Their finality, or their close to finality should be an assurance for voting systems, right?
So I'll give you an example. In the guy, I don't remember his name, but the guy who invented the laser said that the laser is a solution looking for a problem. Okay, but today we found problems that laser solves, and it solves them great. But that's not usually, especially when it comes to actually people, because lasers was like a physics invention. It didn't involve like affecting people's life. We shouldn't force solutions on top of problems. Okay, voting is a very known problem that's been around for centuries, and there's tons of research into it, and it's a very, very nuanced problem. Meaning, as you said, finality is something very wanted when it comes to voting, but it's hardly the only thing that you want. In voting, you want finality, you want privacy, you want something very different than what we call privacy. Because in voting, you want to be able to vote only once without anyone knowing what you voted for, but without you being able to prove what you voted for, which usual encryption doesn't give you, because the second usual encryption lets you prove what you voted for, which is a problem, because if you can prove who you voted for, you can be bribed. Okay? So voting is a very, very nuanced subject with tons of research into and tons of different solutions, some of them cryptographic and some of them very like old and primitive, and these are great. We shouldn't force this new cool thing called blockchain on top of it, which personally I didn't see a single blockchain solution that actually covers all of the nuances in voting.
Yeah, it's even like electric voting is something that we can't figure out. Like, to think that we're gonna form fit a blockchain solution on top of this centuries old problem, like you said, is a bit naive to me. And I guess that's another good topic to get into. Like, what is a good use case for a blockchain in your opinion? Is it only imperative for monetary goods in the digital age, or are there extensions of blockchains use cases that we'll see in the future?
Yeah, I think the exciting thing is to say, I don't know. But again, we shouldn't force anything. We should wait and see, and we should have real discussions. Like, there's a tendency for people, not even in blockchain, in general, when they have this new shiny thing, they want to use it everywhere then they can, even when it's not reasonable. Okay? Blockchains today are very, very inefficient, okay, as databases and as consensus mechanisms even. Like, consensus is also, Satoshi didn't invent consensus. Consensus was talked about since the Byzantine problem, and the Byzantine problem is one of the first ones to actually standardizes what is the consensus problem, but that's been talked about again for more than decades. There's different solutions and every consensus solution is appropriate for a specific problem. I think what we call blockchain is a very good solution for money. I'm not sure what other stuff it's good solution to. Probably there are other stuff, but not as much as we think.
Yeah. No, it's actually one of my favorite people to have this conversation with is James O'Byrne from Chaincode, and he does a very good job of explaining via negativa like why blockchains probably only make sense for a few use cases. But no, that it does look like, especially after 2016, 2017, with the ICO craze of everybody trying to take blockchain and form fit it on every advertising, medical, and travel company in the world. I think we learned some hard lessons in that, as evidenced by the lack of products that have been brought to market.
Yeah, and like we need to remember that even like the simplest requirement for a lot of use cases called privacy is not simple and is very nuanced. Even the fact that you've been to the doctor might be something you don't want to disclose, and even in a future fully encrypted blockchain, fully homomorphic blockchain that no one can knows what happens, you probably can still, at least as we see it today, like correlate a person doing something. And this might be for the medical use case still bad. So like even the word privacy doesn't mean one single thing, and it's very different per use case.
Yeah. No, as you use Bitcoin, you find that out pretty quickly. Like you can blow your privacy simply by going to a block explorer and looking up an address, or not using a VPN when you're sending it out. There's many ways you could be on an ISP that is spying on you and stuff like that. It's an intricate, hard problem to solve. But you have to get back to work here soon. Let's wrap it up with a few questions. I was also stalking your Twitter and saw that you're very angry with the state of cryptography papers and how hard they are to read. What is going on?
Yeah, so this is something that is more like close to my heart. I'm not an academic. I've never been to academia. I have no degree. But I'm really interested in cryptography and a lot of number theory stuff, which is there's a big barrier. I don't know if it's on purpose or not, but a lot of papers and even lectures online, like they don't explain the symbols they use. They don't explain they don't give definitions to ideas. And it's really hard for someone outside of the academia to read those papers and actually understand them. And I want to give a shout out to DJB, Daniel J. Bernstein, which A, he has a lot of great work. B, I think the way he writes papers, and I'm sure others also do this, but the way he writes is he usually gives appendixes and definitions to almost everything, so that when you come to a paper, you can come like almost from scratch, almost saying like you still need to know algebra and you still need to know something, but when you see the sigma symbol, he usually gives, at least in words, an explanation of what does it mean. When he just says finite field, he doesn't just say finite field. He gives an appendix explaining what is a finite field, which I think is very welcome to bridge the gap between the academia and the rest of the world, because algebra might look very frightening, but it's honestly not. But like there is a very big bridge you need to cross that is even today for me it's hard to cross. Sometimes I can read a paper and like need to look up every single thing, and a lot of this stuff you can't even find on Google. So the good thing is we have IRC and people that love to give you answers. But yeah, that's sad. I would love to see papers more self-explanatory.
Do you ever have urges to go through the academic process and learn, or you think that's a waste of time?
Yeah, I'm still thinking of that. It's hard to make a good decision because I honestly don't know too much, because I've never been in the academia of how and why and what. We'll see.
Yeah. I wish you well on that journey to figure out whether or not you want to go on to academia or not.
Thank you.
I hope you can avoid it, because I think you're doing a good job without it at this point. I guess what do you do outside of Bitcoin? Like what interests you when you're not thinking about cryptography and how it applies to Bitcoin?
Mostly I think about Bitcoin and cryptography. Yeah.
I'm the same way. Is there any parting notes or words of wisdom you want to imbue on the freaks out there?
Don't be afraid. I think like a lot of things looks very scary on the outside, but they're not that scary. Like neither does Bitcoin cold code nor cryptography and a lot of other stuff.
Don't be afraid. Some good words of wisdom. Jump into the fray. That's all we got for this week, freaks. Peace and love.